Okay, this is the third tutorial. In the previous two tutorials, we fixed the inverse kinematic basically such that you can move both the FN effector and the position of this card separately with two controllers. And what we will do now, first I will give a quick glance at what the MATLAB thing does. Not that important, but uh, maybe it's useful to get an idea about what everything does and how they're all the things are connected. And lastly, we will do some aesthetic things to make the problem more clear for the user. Okay. So first, what does this MATLAB thing do? I will not go too much into it because I have quite an elaborate uh, toolbox built to abstract things, but maybe it's interesting to get an idea about what is happening here. So this is nothing important for you, but what we will do is basically this for loop. Just we get points from the path, go through all the points that are included in the path, and we extract them one at a time. We have the actual target object, of which we will change the pose to this position, this new position. And then we will wait for the integer signal, so the right controller trigger, to be 1. And if it's 1, we will go to the next point. And what we will do if it's 1 is we will get the joint positions of the entire robot, and we will store it in our solution array. That's basically it. What's happening behind the scenes is, yeah, rather complex, so I will not delve into this, but this is enough to give you a rough idea about what MATLAB does. So now the aesthetics. We had like, yeah, what we had is like ghosts. I don't have the video open anymore, but we had like a ghost object that was like the previous state of the robot, just such that you could see that the robot didn't move too much between the two uh, following states. So now we're gonna do this. So what will we do? We just want, yeah, I know you have ghost objects in VRAP, but the interface has to, yeah, find this object. So let's do the same thing, but not with ghost objects, but with a second robot. So we want the robot from the from this joint on. We don't want to have the track double, but only the card. So let's make sure this is the object model base. What's the effect if I copy and paste this? Now, yeah, the robot from this position on is copied. So if we set this position to 0, you see that we have like two robots. And we don't want this robot to do too much besides just being there. So let's remove all inverse kinematic things attached to that robot. Copy this. This will get a new inverse kinematics. Like delete this. We want this robot just to be there visually and not do too much. So yeah, another thing. No. Okay, now the robot was like a ghost, so its opacity was changed, and let's do that now systematically. So let's make a function for that to change its opacity. I'm too lazy to do it otherwise. So set the opacity of the robot. So how do we do that? We get the children of the robot, so all the shapes that are children of like point where we copied the robot, this joint, all its children, uh, from all of those, we want to change the visibility setting. So uh, let's get the objects in its tree. Let's also get its handle first. Here, 16 joint 0, 1, number 2. It's not the easiest of names, but you have to stick with this. And then we only want a shape type, so it doesn't make sense to have like other objects like the joints and etc. to change those visible properties. It doesn't make any sense actually. So, and if you then make a for loop over all those handles, because this function returns an array of handles, and if we loop over them, and you can find this in the documentation, if we change the made a typo there, shape color, uh, the first one is the handle, which we have. Then the second one, there is the color name. We didn't name the color. Then is the color component, and this is the opacity. Component, component, then uh, let's just copy and paste this to make sure that okay, that's the correct one. And somehow you need to have like 3 values for this function. So how all functions opacity. Let's just copy and paste this from, okay, it's right. So we change this the transparency to this opacity for all the children of this joint. And how these functions work is easily findable online. So if we now change the opacity to 0.1, if we start this, we get, I probably made another typo. My trademark, making typos. Okay, yeah, I found the typo. I had, okay, that was it. So if we run this, we can change the opacity of this robot easily. And if we have another idea about what the ideal opacity is, then we can change this easily to a new value. I found that, yeah, it's actually quite annoying to have this opacity too high. So I will put it low. And the interface is able to read this data, so I will show this to you now. VREP VR interface. Have to wait. So now we see like a ghost robot. So visually that's okay. Now you have to program what that ghost robot does, because if it does nothing, it doesn't contribute anything. You wouldn't want that. So what uh, actually happens is that if we press the right trigger button, we accept the new position and MATLAB will send the new position. But before we press, if we get the joint angles of the robot and we set that to the ghost robot, then that is actually the previous position of the robot. So we need to get that's the strategy we're gonna take. So let's get the joint angles of the robot. So function get joint position, and let's return an array, and we have like 7 joints. So we have maybe important to note that the way we name them is quite similar. So the first one is J0, then we have J1, J2, J3. We are going to use that by looping from 0 to 6 in steps of 1. And that's in the array with the position of 1 element higher. Get a joint position of sim get object, until we're note that we are being quite lazy here. For KR16J, and now we are concatenating strings in Lua. So we are adding what the index of the loop is at that point. Then just add 1 after it to make it work, and then 1 extra bracket, and then this should get the joint positions. We have to initialize this process by getting calling this the first time. So yes, like this. So we have the initial joint angles saved, and then now we already prepared this. Uh, we also need a set joint position function, which is almost exactly the same. But let's not waste too much time about this. Okay, that should work. I probably made a typo there, but who cares? So if the trigger is pressed, then we want, before we move the robot, get the joint position. So set joint positions. Yeah, I made a mistake there. We saved it in joint angles, and then joint angles is the new one for if they change in a future repositioning. That joint. Yeah, those names are all good. But the thing that's wrong is that we need to not set the joint position of the visible robot, but the ones of the ghost robot. And these are actually quite the same, except that we need to change them like this. So if we now run this one, this one is stable enough to handle this. I keep forgetting that and restarting it, but actually it's not necessary. Show you what's happening. Like now the ghost robot is here. If I press is probably snap there, and if we move now to here and reposition the end effector, then we see like a ghost-like silhouette. If we repress it, then we see it follows the previous position. So this works. No typos. Who would have imagined? Okay, uh, and this is basically all the functionalities that I used in that video. So uh, you're up to speed how I did this, and you can do this for yourself now and use the tricks, or not really tricks, just using VREP to do similar things in your application. So I hope you enjoyed the video and everything was clear. I will probably add this scene to the VREP toolbox repository. The only problem is that this mesh is quite large, so it will take a lot of data, but why not do it? So bye.